Welcome. We present a process for recycling wind turbine fiber reinforced composites that has great potential for scale-up thanks to the use of inexpensive reactants, operation at atmospheric pressure, and high yield of well-preserved products. Chemical recycling methods best preserve the value of the fiber and polymer. However, many chemical recycling methods use highly corrosive chemicals that do produce undesirable byproducts and damage the fiber. Mild catalytic methods have gained favor because they don't have these negative effects. The problem? Existing mild catalytic systems either require high pressure to reach high reaction temperature or require uncommon, expensive solvents. High pressure and expensive solvent both impede scale-up. Our process, instead, uses a high boiling point industrial solvent and can operate at ambient pressure. During the initiate phase, we optimize the reaction conditions so that thick composites can be recycled in a single step while using much less catalyst. We have also worked to optimize the separations process, which accounts for the majority of the energy consumption. This is done by increasing the concentration of the decomposed resin in the solvent. Less solvent used means less solvent to separate. However, as the concentration of decomposed resin in the solution increases, it becomes more difficult to clean the decomposed resin from the fibers. To address this, we have developed a countercurrent reactor. The reactor consists of 4 1-liter steel vessels with electrical heating jackets. Each has independent insulation and thermal control with dual thermocouples. The valve configuration allows parallel and series operation. The reactor is operated within a fume hood for additional containment. The reactor is configured as follows. A pump circulates the catalytic solution. Valves are configured such that the clean reactive solution enters the reactor unit containing nearly clean fibers. The solution proceeds through the next reactors, becoming darker in color as it accumulates decomposed resin. The highly concentrated solution then exits the decomposition train for separation. Meanwhile, in a unit that has been isolated, large segments of wind turbine composite are placed in a basket and lowered into the reactor. The valve configuration is then changed, sending the fresh reaction solution to the next unit. The recently loaded composite is exposed to solution with the most product, initiating swelling and decomposition. The other units are exposed to progressively cleaner solvent. The reactor that has reached completion is isolated, drained, and purged. The fiber is removed and a new segment of composite is loaded. The operation proceeds in this manner, allowing for a block of composite to be decomposed to residue-free fiber with minimal handling of solids. Here, a 1 by 2 by 4 inch section of wind turbine blade composite is placed into the reactor basket and loaded into the reactor unit. The unit undergoes a reaction cycle, and the fibers are now liberated from the matrix. The non-volatile decomposed matrix resin has been removed, leaving only fiber and volatile, water-soluble solution. This solution can easily be cleaned off in water or evaporated from the fiber surface at around 200 degrees Celsius, yielding long, clean fibers.